Hello everybody. Today we're going to do some examples finding the transformation form of a function by completing the square. So let's start by looking at a function f of x equals x squared minus 8x plus 2. So the first step would be to identify the value of b, which is the coefficient in front of x. So that would be this positive 8 right here. So b is going to equal 8. Okay. And then what we have to do is we have to complete the square on the x squared minus 8x term by adding b over 2 squared, which is going to be 8 divided by 2 squared, which becomes 4 squared, which is going to equal 16. The next step would be to add and subtract 16 on the right hand of the expression for f of x. So we slide in that, we add 16, subtract 16, and the reason for the subtracting 16 is that the net that we've added to the previous expression, if I add 16 and subtract 16, that's like we've just added in 0, and what we would be left with would be x squared minus 8x plus 2, which is what we started with. So the whole point of we add 16 to complete the square, but we subtract 16 so that we are not changing the expression that we started with. Now the next step would be to look at your first three terms in the expression for f of x squared minus 8x plus 16. Now that we have added that 16, we have made the first three terms such that they're going to factor into a perfect square. The next step, the first three terms, x squared minus 8x plus 16, since b was 8 and we divided by 2, our value of b over 2 would be 4. So x squared minus 8x plus 16 is going to factor as x minus 4 in parentheses squared. And then we still have the minus 16 and plus 2 left on the outside of the x minus 4 squared. And the final result, f of x in transformation form, would be x minus 4 squared minus 14. And the vertex then, if we read it off, is going to be the point. Well, the x-coordinate, when you look inside the parentheses, you have an x minus 4. Whatever you're subtracting from x becomes the x-coordinate of the vertex. When you notice that inside the parentheses you have this x minus 4, that means that the x-coordinate of the vertex is going to be positive 4, and the y-coordinate of the vertex is going to be k, which is going to be the minus 14. Okay, so it's whatever you're adding to your perfect square. So now that we have the transformation form, which allows us to read the vertex right off, we can go ahead and plot the vertex. So here's an xy coordinate axis. This point down here in green, I have moved right 4 units and down 14 units to plot the vertex. And now what we want to do is we just want to plot 2 other points, and then we can fill in the graph with a parabola, since we're working with a quadratic. So on this slide I've rewritten the function again one more time, and I guess I can write down the coordinates of the vertex, which would be 4 comma minus 14. And what I've done is I've picked an x value less than the x-coordinate of the vertex 4, which positive 2 works. I generally like to stay close to what the x-coordinate of the vertex is. And I will also choose something that is greater than positive 4, like positive 6. And now what we'll do is we'll go ahead and compute f of 2 to get the y-coordinate. F of 2 is going to be 2 minus, f of 2 is going to be, in parentheses, 2 minus 4 squared minus 14, which is going to equal, inside the parentheses you're going to get negative 2 squared, which is positive 4, minus 14. This ends up being minus 10. So that gives us the point 2 comma minus 10 on the graph. And f of 6 is 6 minus 4 squared minus 14. 6 minus 4 squared, that's 2 squared is 4, minus 14 also gives you a minus 10. So we can add in those 2 points. I've added the 2 comma minus 10 and the 6 comma minus 10, and then from here we can just fit those points with a parabola. And my drawing skills aren't so great. I should have made sure that, if I go back here a couple strokes, I maybe should have made sure my graph was a little more rounded out at the bottom down near the vertex. Okay, so when you're graphing these quadratic functions, the best thing to do generally is to pick off what the vertex is by putting it in transformation form. You can also use the vertex formula that I'm going to show everybody in class. You can find the vertex with a formula, and then you would just again plug 2 other x values into your function to get some y values. That would give you 2 other points on the graph, and then you can fit the points with a parabola. So let's do another example where this time the coefficient on x squared is going to be something other than positive 1. Okay, so this is what we call a non-monic polynomial. The previous example is what we call a monic polynomial because the coefficient of x squared is positive 1. So the focus again when we start these off should just be to focus on the terms that contain a variable x. The next step then is in those first 2 terms, the coefficients 2 and 8 both share a factor of 2. So the first step before you can even complete the square is you want to factor out your value of a, which here is positive 2, which leaves us with an x squared plus 4x. What I'm going to do first is I'm going to ignore the positive 2 that I have now factored out in the minus 5, and then within those parentheses to the x squared plus 4x we will now complete the square. The value of b in this example, b is going to be positive 4, so b over 2 squared is now 4 over 2 squared, and 4 divided by 2 is 2, and 2 squared is positive 4. So inside the parentheses you can add 4, and again you must subtract 4. We need to add in 2 terms whose net sum is 0. This way again that we are making sure we are not changing the value or the expression for f of x. Just like before, I'm going to add some parentheses around those first 3 terms inside the parentheses. So the x squared plus 4x plus 4, we should be able to factor that as a perfect square. So I've put that in parentheses. So now, again, the x squared plus 4x plus 4, I've inserted those green parentheses, and in the next step, the coefficient 2 is going to stay out front, and then instead of using parentheses, I chose to use brackets, and the x squared plus 4x plus 4, you can see in green, I have written that. It is now factored as a perfect square, x plus 2 squared. We still have a minus 4 inside the brackets, and then we have our original minus 5 coefficient outside of the brackets. Now, if you look inside of the brackets, we now have 2 terms. X plus 2 squared would be the first term, and minus 4 would be the second term. So what we can do is this 2 out front can be now distributed to both of those terms. So we would get 2 times x plus 2 squared. That's what we get when we distribute the 2 to the x plus 2 squared. And then we distribute the 2 to the minus 4 to get minus 8. And we still have this minus 5. The minus 8 minus 5 is going to give us a minus 13. So f of x becomes 2 times x plus 2 squared, and then minus 8 minus 5 gave us a minus 13. So this would be our final transformation form. And that's going to allow us to read off the vertex, which is going to be, now if you look up here inside of the parentheses, you have an x plus 2. That's really x minus negative 2. Again, the one thing you can remember is whatever you're subtracting from x is the x-coordinate of the vertex, the value of h. If you see an x plus 2, that's really x minus a negative 2. So the x-coordinate of the vertex is going to be a minus 2, and the y-coordinate of the vertex is the minus 13. That's our coefficient after our perfect square on the back. And again, what we could do if we want to graph this function, we can plot the vertex minus 2 minus 13, and then we can pick x values to the right and to the left of negative 2 on the x-axis, plug those into the function to get the y-coordinates, and that would give us 2 other points. So keep your eye posted for more videos. My goal is to get a video for section 1.7 posted by Sunday, hopefully even by Saturday. If I could do that, if you can see the Canvas announcement and watch that video before class, that would be much appreciated. Everybody have a good weekend, and thanks for tuning in.